This project upgraded weather stripping, insulation, and heating and cooling systems with cold climate air source heat pump technology in 11 townhomes. Most buildings had forced air gas furnaces, and we were looking for ways to manage overall costs.
As we were evaluating air source heat pumps, an important consideration was to avoid having to upgrade the electrical panels to a higher amperage service if possible. To upgrade from an older panel of, say, 65 or 100 amp service to 125 amps can typically cost a few $1,000s. Adding new loads like a heat pump with electric backup, you may find that 100 amp capacity is not sufficient. This can trigger that upgrade to a higher capacity panel, typically installed by an electrician in consultation with your local utility. Our strategy was to start by upgrading the building envelope. This reduced the building's heating load and enabled us to retrofit with a smaller heat pump that would otherwise have been needed.
Reducing the home's heating load has multiple benefits. You can install a smaller heat pump system. You can reduce the need for backup or supplementary heat, which can reduce project costs. Finally, you may avoid the need for panel and service upgrades from your utility company, which again can help reduce your overall project costs.
Our approach was to model the heating load resulting from a better envelope and the corresponding downsizing of the air source heat pump. Since we were able to bring the loads down, we only needed a small 3 kilowatt supplementary backup heater. We anticipate that this system will only operate, say, about 5% of the heating season, which is not very much at all.
With the upgraded insulation and weather stripping, this amount of backup heat would be enough to keep the pipes from freezing and allow reasonable time for the maintenance crew to perform emergency air source heat pump servicing.
One of the questions we asked ourselves was, should we size at the design load or size for a little less and cover the coldest periods with electric backup? The cold climate heat pumps we specified should provide most, if not all, the heating, even down to minus 20 Celsius. However, as the outdoor temperature drops, a heat pump's output capacity also drops, and it needs a helping hand. Fortunately, if the heat pump is properly sized to begin with, this situation would only occur less than 5% of the time.
In this case, we reduced the building's heat loss by about 70% through selective use of building envelope upgrades. This enabled us to install a much smaller heat pump than would otherwise be necessary. It also resulted in a smaller supplementary backup heater, which avoided the cost and trouble of having to upgrade the electrical service.